The PS2 protocol allows a host to listen to a mouse or a keyboard and get the input from these input devices and interpret them to do something useful with them. It also allows a host to send commands to a mouse or a keyboard so that you can change some internal configuration. For example, you might want to change the speed at which the mouse is actually sending you data, or the resolution of the mouse, or the speed of the key presses on the keyboard, or something like that. Before I jump into the details of how the PS2 actually allows a host to send commands, I just want to remind you that the PS2 bus consists of only two signals. These are PS2 data and these are PS2 clock. So this particular diagram in here shows me several signals, but there are actually only two. The reason why we're showing you several signals is because I want to show you which of the two, the host or the device, is actually doing what to which bus. So in here, I'm showing you the PS2 data, the host, how the host actually when the host controls it, what does it do with it? And in here, I'm showing you the device, the PS2 data, but I'm showing you from the device perspective and what the device can do with it. The same goes in here for the clock. For example, the one on the top tells me this is what the host is doing to the clock signal or the clock bus, and in here, it's telling me what the device is doing now. Okay, so let's dig in and see what the protocol does. So initially what we have is we have in idle, we have both of the signals, the clock and the D are actually high. So it seems to be in this diagram, I'm showing you that it's actually from the device, because most of the time the device is actually sending data to the host because they're input devices. So we're going to assume that the device is, generally speaking, in control of the bus. So when a host wants to send that device, which is a mouse or a keyboard, some command, what you need to do is you need to stop that mouse or keyboard from its activities. So you want to inhibit the activities. And the way you do it is actually the host takes first, what it does is actually goes to the clock and it drags it to 0 for about 100 microsecond or 0.1 millisecond. So during that time, no matter what the device is doing to the clock, it's going to be at 0 because it's connected to ground. And this indicates to the device that, okay, the host is trying to stop me from doing whatever because it wants to send me some command. And we can think about it as a request to send. This is how we can actually interpret this particular signal. So during that time, the clock is inhibited. So technically, you can think about it as the host is in control of the clock signal. So what the device does is actually releases that. That's how we can think about it. So at the same time, what we have is, because now the device knows that basically the host wants to send something, so the mouse or the keyboard knows that the FPGA board or the PC wants to send me something, so it will release the data line because it knows that basically it needs to listen to that data line, so it knows it. So what happens is it connects it, basically puts it into into high impedance. And at that point, the device actually takes over. And during that time, when the device takes over, it starts by setting the data line to 0, and this indicates a start bit. And during that time, at some point, the device takes over the clock again, because remember, the device is actually the one that generates the clock, not the host. So the host just takes it to 0 just to indicate that, hey, stop everything you're doing because I want to send you something. And then it releases it back. So the clock actually comes back and just says, okay, I'm going to generate the clock. And to the end, then it just generates the clock all the time. And then the device goes, or the host actually goes and says, okay, here's my D0, here's the D1, all the way to D7. So it sends that one byte that it wants. And also it sends a parity bit that it computes so that the device can actually figure out if it received the data correctly or not. Okay, so what we see in here is that the device, or the host actually, not the device, the host actually does everything on the negative edge. Kind of like similar to reading, it also, when it actually shifts out a new data bit, it shifts it on the negative edge. So the host always is activated on the negative edge of the clock all the time. So the negative edge, negative edge, negative edge, it's always at the negative edge of the clock. That's how we have it. Okay. At the very end, when the parity bit is sent, what we do is actually the device issues a stop bit in here, basically drags it to 1 or drives the data line to 1. And this indicates to the device that, or the mouse or the keyboard, is actually the transmission is done, and it releases the data. It releases the data signal and it gives it back to the device. The device it doesn't have to, but it usually acknowledges with a 0. So it drags that data line into 0, or the data signal into 0. And the host can actually read this if it just wants to make sure that the packet was sent correctly or whatnot. And then it just takes control over that bus again. Okay, from here, basically the device takes control over it. What I want you to pay attention to is for how long does the host takes control of the clock signal. The host only takes control of the clock signal for a very short period of time. Again, the device is the one that generates the clock. We only utilize the PS2C on the host side. Basically, the host only takes the clock for a very short period of time just to indicate the RTS. And that is the reason why we have that PS2 clock is actually a bidirectional signal. It's just because of this particular thing, we need the host to actually send data on the clock, even though it's always receiving it. It's just for that particular signal. Other than that, you can actually take a look in here. The data, when the host is communicating or sending data to the device, you will see that the data is mostly under the control of the host, mostly. So it's only when the request to send and the stop signal where it actually takes care. Like basically, the device only takes the data line or the data signal only during the request, or only before the request to send, and only at the stop bit, and that's it. The rest of it is actually the host is in control of that bus.